I just discovered a pattern that's going to help us eliminate $1 million worth of risk. What did you do today? Oh, you built a new PowerPoint documenting the architecture. Great, thanks.
In this episode, we're going to take a look at data chaos in the cloud and talk about some of the implications of data and the cloud in a realistic format. The first thing I want to talk about is that you coined the phrase data chaos in the cloud. What did you mean by that?
I meant that it is a place where we throw things we don't have any other way to deal with. So sometimes it's in the cloud. By the way, it's not always in the cloud. Sometimes it is in file systems on premise. Some people call that the data lake. Some people call it the data landfill, but it just depends on your point of view. It's chaotic because largely it is part of a presupposition that we don't know what it is, and we won't know what it is until we decide to use it, but we're keeping it in case there's value there. We talked about this last time. And folks are taking data that they know is likely to have value at some point and putting it in with the presumption that we'll get to it, and when we get to it, we'll parse it first, and then once we've parsed it and we know what's in there, we'll pull out what we have to have. This is called schema on read. Schema on write, is another whole problem. But if I know vaguely what's in that file, and I know that I can chop my way through it and pull out the bits that I need, and it is not of very high value with high frequency usage, then it's simpler and much less expensive to put it either in the cloud or in a file system like Hadoop that we've been talking about.
So how is this difference? What's the real difference between the cloud-based data architecture and the in-house data architecture, and how is it causing this or creating this problem?
Well, the first order of magnitude answer to that is capital. Cloud is operational expense, in-house is capital expenditure. So if you're my CFO and I'm your CTO, and we're sitting down today, and I've got 3 proposals for you for that project we talked about recently, and one of them is in the cloud, there's a good chance you look across the table at me and say, Merv, this cloud thing, how ready are we? How ready is it? 3 years from now, the likelihood is if we have the same conversation and none of those 3 is in the cloud, you say, what are you trying to do with my capital budget? I don't want to buy more hardware. I don't want to build another data center. So the biggest difference is how we spend on it. We rent cloud capability. The storage tends to be persistent over time, but the compute spikes on demand. I talked to a gentleman from a company that manufactures universal remotes at an Amazon Web Services conference a year or so ago. And he said, when people get those, they log onto our website to figure out how to configure it. When do you think they do that? And I said, I don't know. He said, well, 3 days after Christmas, 2 or 3 million of them. And for the rest of the year, a few dozen a day. So what I want is an environment where I can get the capacity for those 3 days I need and then immediately spin it back down. I don't want to buy a data center for 3 days worth of work. So the cloud is a really good place to do that. And most organizations who are working with big data today are experimenting. They're doing their first test and dev projects. And doing that in the cloud makes a lot more sense to them, given that they don't know how much value they're going to get out of it yet, than buying what is probably a rather large, even if composed of inexpensive pieces, framework in which to do it.
So how does this, if I'm an information architect, how does this change our architecture?
It regularizes the notion that we're going to have a sandbox, first of all. And that really, all by itself, is a big departure. We used to only do things we planned for carefully in advance. And now we recognize that there actually is a role for experimentation. That's also a cultural difference like the one we talked about in our last discussion, where the insurgents who are coming into our data centers are opportunistic. They're bottom-up thinkers. They are playing with the data and looking for things they might find, and they'll come into your office if you're the head of IT and say, I just discovered a pattern that's going to help us eliminate $1 million worth of risk. What did you do today? Oh, you built a new PowerPoint documenting the architecture. Great, thanks. So we have to be able to encompass that in our model and leave room to go experiment and maybe fail, but hopefully fast and hopefully cheap.
So you've mentioned some key actions that information managers have to take. What are those, just in summary?
Audit, number one. Understand the information you've got. Understand the capabilities and activities of the people, whether they're in your IT organization or not, who might help you to get value. think about how architecturally it might or might not fit and the degree to which it might or might not be redundant with things you're already doing. The last thing we need is yet another set of copies of data if there are methods we can use to operate on it where it is. And last, think about the economic value of the data and treat it like the asset that we keep saying it is. This is a whole theme of thinking that we've got called infonomics, which says if you really treat it like an asset, you will behave differently. I'll take the data that isn't worth as much and keep it in cheap stores, maybe the cloud. I'll take the data that's expensive, inherently valuable, or used frequently, and put it in an environment that allows me to do that, obviously as cost effectively as possible, but the parameters are different.
This has been our discussion with Merv Adrian, the Research VP with Gartner Group. Some fascinating discussions on DBMS, databases, and data management.